Okay, so hey, this week we'll cover 8.1, 8.2, and 8.3. We'll review, and then we have a quiz after we take our review. So really the first three sections are all about the graphing portion of exponential functions. That's kind of the first half of the chapter. In the second half, we get into the properties of exponents. Okay, so the graphing is going to give you kind of a bit different graph than we've seen in the past. Some of you studied this in previous years, but we'll get through it. So if you need help on this work together on page 362, actually get out a piece of paper. That'll be helpful to you, okay, if you can't figure it out without it. All right? So go ahead and work with the person next to you. You may need a textbook, page 362, they're over there. Here we go. Okay, let's see how we did. After, zero folds, we had one rectangle. 1, 2, 2, 4, 3. What happened? 8. 4. 5. 6. How many? Or I guess 10. 10 is 1,024. This would have been 6, yeah. Unbelievable. This is 10. How many of you actually were able to fold it 10 times?
That's impossible. You can't fold any piece of paper past 7 times.
Really? I'm not sure about the possibility, but I do know if you were able to fold it 10 times and then you had to count that many rectangles, that'd be tough. Hey, how many have actually got to the 10th fold, and you were able to figure that number out? Maybe you didn't fold it 10 times. Okay. Hey, we're dealing with powers of 2 here. This is 2 to the 0. Anything to the 0 power. This is 2 to the first power. This is 2 to the second. 2 to the third. Remember, that means 2 times 2, which is 4, times 2 is 8. 2 to the fourth, so 8 times another 2 is 16. Notice we're multiplying by 2 here. So how many times have we multiplied by 2 to make 8? 3 times. So 2 to the first, second, third. 2 to the third. We go to 16, that's 2 to the 4. We go to 32, that's 2 to the 5th. Notice we multiplied by it 5 times. Well, this is 2 to the 10th. So if you weren't able to actually fold your paper that many times, if you did 2 to the 10th on your calculator, you'd be able to get that. Bless you. How many of you played? There's this game I was told about this weekend called 2048. How many played that?
I do.
It's an app. 24. Have you guys ever got 2048?
It is so hard.
Have you ever got to 1024?
Yes.
I got to 512, but it is really difficult because you've got to keep. How many of you played the game? All right, hold on. I got to put the game.
Hey, I have it.
I got it right here. I got a mammoth screen on my phone, so it's a beast. Let me see. Hold on. There's Flappy Birds. We don't want that. No, that's pretty good. All right. So this game, I really don't want to restart my game right now because it's tough to get that far, right? Those of you who play, you know. But so here's the game. Let's restart. It saddens me. Yeah. Okay. So we have 2 to the what power? 2 to the first power. Okay. So 2 to the first. Now, if I put those 2's together, that's 2 plus 2. That's 4, right? And I put those 2's together, and that's 4. And 2 to the second times 2 to the second is 2 to the. Well, we have 2 to the third there, right? That's 4 plus 4. That's 8. So all of these are base 2. It's 8. That's 16. We'll never get one of these numbers that's not base 2. After we get 16, 16 and 16 is? 32. You guys are going to... This game is so addicting. Like, I can barely...
because you can't beat it. It's like impossible.
You can beat it.
Why?
But check it out, dude.
Combine the 16.
Yeah, if it's combined to 16. The point is to make one of these tiles equal 2048, which is like way tough. You just keep doubling. It's a power of 2. The kid that showed me this used to be my neighbor. He's like, hey, this is a math game. I convinced my teacher it's a math game so I could play it during class. I'm like, all right, let me try it. And then I was stuck playing it the whole time we were eating lunch. It was ridiculous. So, anyway, you're continually doubling, which means it's a power of 2, 2048. So those of you, when you guys play this game, I just want you to know you're doing exponential growth on it.
Seriously?
Yeah. I know. So play the game. Not right now, though. All right. So, by the way, you would have to combine how many tiles to get 2048?
Are you talking about 2,000?
2048, which is one more power. One more times 2 from 2 to the 10th. So that means it's 2 to the 11th. And the tough thing about that game is you have to, in order for that to work out, you have to form, notice when I'm doing this, in order to make the next, so in order to make a 16, I have to put 2 8s together. All right, so I can't get, let's see. So I have to put 2 8s together somehow. So right here, I'm going to be able to put these 2 8s together, and that's going to make a 16. So in order to make a 2048, I have to put 2 what together? 2 10,024s, which means I have to combine 2 to the 10. I have to combine to the 10th power a bunch of times to get 2 1024s. It's tough. So it's a tough game.
I know you can get that.
I know. I'm like, dude, I'm addicted right now, so we got to put it in. I just been playing it all day. All right. In fact, I did. In between that and planning my lessons. It's like, dude, that's what we're doing this week. Okay. Very good. So when we're dealing with exponents, let's kind of write these in exponential form. It's number 6. Just on your paper, let's put these. Let's start with just these 2. Write those 2 in exponential form. I should get props for putting that. I should get some kind of money for advertising that game or something. There's got to be something involved. Either that or I just infringe some copyright or something. This is 3 to the 4th. Repeated multiplication is a power. Remember, that's different than this. 3 plus 3 plus 3 plus 3. That's 3 times 4. That's 12. Okay, 3 plus 3 plus 3 plus 3. This is 9 times 9, or 81. Okay, so this one's 3 to the 4th. This is negative 2 to the 3rd. Now remember, whenever you're raising a negative to a power, you want to put parentheses around it. If you write it like this, that means 2 to the 3rd times negative 1, which in this case would give you the same answer. It would give you negative 8. However, if you're doing, say, this one, negative 2 times negative 2 times negative 2 times negative 2. That one is negative 2 to the 4th, which gives you 16, versus if you write it like this, that means negative 1 times 2 to the 4th, which is negative 16, if you write it like that with the power. So if there's a negative, always make sure you put those parentheses. Any questions? All right, I want you to work with your neighbor, figure out how to write that one as an exponent. Okay, 2 ways I can think of. What's one way? What did you get? 5 to the 3rd. I saw a few of you had that. Who had that? 5 to the 3rd. 5 times 5 times 5. 5 to the 3rd. What's another way? Dan?
1/25th to the first power.
Good. 1/25th to the first power. I know, that's kind of unbelievable. Well done. Okay, right now, everyone rate themselves 1 to 5.
10.
Okay, that's not to 5. Okay, let's move on. The next piece, nice. The next piece Let's see if we can evaluate exponential functions. Actually, you know what? Before we do that, or actually while you're doing those, I'm going to hand out your assignment, okay, that we can be working on. All right, I want you to evaluate those. In other words, plug x in. Plug 1, 2, and 4 in for x. So you're going to get how many answers? 3. Your input is 1. Put it in and get an output. Then your input becomes 2. Put it in and get an output, and so on. Okay, hey guys, really what this is doing, this is trying to get you ready for graphing these. Okay, so you're given an input, which a lot of times we look at like this. This is our x. This is our input. We're trying to find our output, which is our y. This one's drumming, maybe. Okay? And then we have a rule. What's our rule here? Oh, 2 people. Come on, man. How about more people? Not that I don't like you two. Kalina? Good. It's this part right here. 3 to the x power. So if we put in a 1 for x, that's 3 to the first. Gives us 3. Anything to the first is itself. That means you're multiplying 3, or you just have 1 3. I guess you're not multiplying by any 3s. Okay? 3 to the second, when we put 2 in, the only thing that changes is the x value. That's 9. We put 3 in. Okay, so this is one that we didn't have to do, but all you're doing here is substituting. Here's your input, you put 1 in, you get your output. Here's your input, you put it in, you get your output. Okay? I think you got it. Okay, so why would we actually go from equation to this table? What would be the benefit of the table? Yeah, to get y. It gives us coordinates, right? What coordinate is this? 1, 3. This is a coordinate.
2, 9.
And
3, 27.
good. Okay, so we could actually graph now, right?
Yes.
Okay, that would be the next step. We could also use the table to make predictions. Okay, yeah.
How would you graph 81? Graph it,
We'd have to, yeah, it wouldn't go up to 10. Like our graph would have to change, which we'll see here in a minute in terms of our
Would it
scale.
go by 10?
Yeah, it might be going up by 10s or by 5s or, yeah. Okay, any questions there? All right, I want you to try number 8. Okay, let's check our inputs and outputs. So, x, y, our rule is 100, oops, wrong spot, 100 times 2 to the power of x. The only thing that's changing in each of these is? What's the only thing changing?
The exponent.
The what?
The exponent.
Yeah, the exponent or the x value. So I'm going to write all of this 3 different times. Because that's the only, that part's all staying the same. The only thing that's changing is my x. So they're telling my inputs, 4, 5, and 6. So 4, 5, and 6. They don't tell you inputs. You can pick any values you want. Okay? I'll give you some hints on which ones to use. But there's 4, there's 5, and there's 6. So do I do 100 times 2 or 2 to the 4th first? What comes first? Go ahead and tell your neighbor, 2 to the 4th or 100 times 2? Okay, let's vote. How many say 100 times 2? How many say 2 to the 4th? Some of you didn't vote? Come on, you got to vote. Pick a side. 100 times 2 or 2 to the 4th? Who says 100 times 2? Who says 2 to the 4th? The answer is 2 to the 4th. You think back to PEMDAS, parentheses, and then exponents. Exponents comes before multiplication. So 2 to the 4th is 2, 4, 8. 2, 4, 8. Hey, right here, look at me. Don't use your calculator. Look. 2, 4, 8, 16. 2 to the 4th. That's how you do exponents. You do them on your fingers. 2, 4, 8, 16. Okay? 3 to the 4th, 3, 8, or 3, 9, 27. 81. Yeah, come on, you can do them. All right. 2 to the 4th is 16. 16 times 10, or 100 is? 1,600. Okay, 16 with 2 zeros at the end. 2 to the 5th is, just multiply 16 by 2 is 32 times 100? 32 hundreds. Okay, 2 to the 6th. 64, you double 32. 64 hundreds. For those of you that play that game, you should recognize these numbers, man. I mean, those are the numbers. The next one is 128, and then 256, and then 512, then 1024, and then 2048. I know, it's an amazing game.
What size number you got there?
I've got to 512. I've almost had 2 512s. Yeah, it's free, and it's freely addicting. Stupid game. Okay, I want you guys to pause there and go ahead and take a look at your assignment. On your assignment, before we move on to the next piece, I want you to spend some time filling out these tables and making your getting your outputs for these inputs. Now, I personally like the table form of doing the outputs like we did on here. Okay? So when you're doing, say, number 4, which looks very similar to this number 4 for some reason. That's odd. Actually, it's an even number, but it's an odd problem. Okay? Those number 4s you've already done. Okay? Number 8. Is it the same number 8? Yeah, some of you are paying attention. Good. Yeah, number 8, they're the same. All right? So you already done those two. I personally like the table form. Okay, when you're doing your outputs. All right, very good. I'm going to give you about, 5 minutes, 6 minutes to work on this sheet, ask questions, and then we're going to move on to the next piece. Okay? Here we go. We doing okay on these? Okay? Hey, about another minute, we're going to move on to the graphing portion. Okay? So get to a good stopping point in the next minute here. Okay, let's go ahead and move on to the graphing part. The first thing I need you to do is write down that information. We're going to cover this quite a few times this week, so hopefully by the last time we get to it, it'll be so ingrained in your mind that it'll be easy for you to remember. The standard form of an exponential function is y equals ab to the power of x. Now, if you think back to all the functions we've done this year, we've had linear, we've had quadratic, we've had absolute value, we've had square root functions. All of those, the x value has moved positions. In this one, x is now right here. It's up in the power position. So Dan, you're right. It's up there in the exponent position. All right? So one of the ways to kind of categorize the different things you learn in algebra is just think of the different patterns. We have the linear, y equals mx plus b. We have quadratic, y equals ax squared plus bx plus c. In all of those, we had different pictures. We had that for linear. For an example, we had y equals ax squared plus bx plus c. We had our quadratic picture. We had y equals the root of x. Okay, so thing like that. We had y equals the absolute value of x. Of x. So remember that was a V shape. Okay, so our different families of functions, this is another family. And this one has a picture as well. Notice here x was to the first, here x is to the second, here x is in the radical, here x is in the square, or in the absolute values. Here x is an exponent. And when you get to advanced algebra, you're going to add about 10 more families of functions that you're studying. Okay? So you have about 14 different families you study. All right? So this is the fifth one here. All right, y equals a, b to the x. A is our starting point, the starting amount. It's your y-intercept. So if you're drawing a picture of this, your picture, zoom out a bit so I can put it on the edge here. Your picture for this one would be maybe something like this. Okay, that's a growth function. This is where your a term is. That's your starting amount. It's your y-intercept. This piece right here is your a. Whatever that value is what that point is. It's where it crosses the y-axis. B is your base, or your growth factor, or decay factor. So when you were multiplying by 2 every time, that's a base 2. When you're multiplying by 3 every time, that's a base 3. So in these problems you just did, these patterns right here, on your assignment, what were we multiplying by on this one? Yeah, 2. You're doubling every time, right? You went 800, 1600, 3200, 6400. This is base 2. What were you doing here? Doubling from here to here, doubling again, doubling again. This is base 2. Here, what were you doing?
Tripling.
You're tripling. So this is base
3.
3. Okay, your base is what you're multiplying by every time. Okay, and then x is the number of times you're increasing. All right, here we go. Let's try this problem right here. Y equals 4 to the power of x. All right, so the first thing we need to do is understand the y-intercept is always when it crosses the x or the y-axis. That means x equals. What does x equal right here? Okay, let's trace the x-axis. Someone tell me when I get to the y-axis while I'm tracing x.
Stop.
Okay, stop. Where am I at on the x-axis?
1, 0.
I'm at 0. The y-intercept is always when x is 0. That's where we start. So someone was asking that a while ago. We're going to put our rule up here. We're always starting right here. So this is 4 to the x. So notice the only thing that's going to be changing this whole time in this problem is the x value. Okay, so here I'm putting 0 in. 4 to the 0 is? Anything to the 0 is? 1. Okay, so if you didn't know that, make a note of it. Anything to the 0 power is 1. And you'll notice the term, the a term. What's our a term right here in front of the 4? It's 1. Okay, we don't see it. We don't show it, but it's a 1. Remember y equals a b to the x, the form we just put up? Well, our a term, if there's only one number, the a is 1. That means it's crossing at 1. I'm not going to put it there yet because I don't know if my scale is going to be going up by 1s. Okay, well let's try to put 1 and then 2 and 3 and -1, -2, -3. Let's see how that works. Sometimes that works well, sometimes it doesn't work well. What we want to be able to see is what's called the curve. Okay, this graph should look like this when we're done. It should have a curve to it. We need to see that curve. What's 4 to the negative first? Yeah, 0.25. Some of you are putting into your calculator getting 0.25. Later on, we're going to talk about how to do that exponentially. But for now, if you put it into your calculator, yeah, you're getting 0.25. Here you're getting 0. What? 625? 0.625. Okay. And negative third? 0. It's getting really small, right?
0.0156525.
Okay, so it's getting really small. 5625. Okay, so I'm going to go up by, well, if I want to get all this on here, if I want to get the 64, I've got to go up probably by 5, 10, 15, 20, 25, 30, maybe 10s, 10, 20, 30. But most of my values are below 1, right? Okay, I'm going to go ahead and go up by, I'm going to ignore this last piece, the 64. I'm going to go up by 2s. 2, 4, 8, 16, or 2, 4, 6, 8, 10, 12, 14, 16. Okay? So I'm going to graph these. That's 2, 16. 1, 4. 0, 1. And then I have all these like small guys here. I mean, ones that I can't even get, like they're getting really, really close to 0, but they never get here. What you want to see is this curve right here. See how it starts going up really fast? And the next one would be 64. I mean, that's like way up here. This almost becomes a straight line going up. I want to be able to see that curve when we're graphing. Okay? So everyone take a look back at your assignment. We just did number 16. Now notice I didn't put as many lines on here, as many spaces to fill in, but I want to be able to see the curve. So if you can't see the curve when you're done graphing, then you have to keep going. All right, for now, let's cross out these right here. Okay. Now, how many of you almost finished the front earlier? Okay. So what I want you to do is I want you to spend time getting this done. Try to get your graphs done. You've done this one. Okay? You've done most of the front. Get these graphs done. Remember, when you get down to these, raise it to the power and then multiply. Spend at least a half hour on it tonight, please. Okay?